Okay, so this is day 150. I want to talk about the 4 terms that will help you organize your thinking, okay? The 2 terms I've talked about are arithmetic and geometric. Arithmetic is either linear or exponential. What is arithmetic?
Linear.
Linear, right? It goes up or down by the same amount, the same common difference, okay? Geometric is exponential, okay? Exponential growth or decay. Okay? So, again, arithmetic is what? Geometric is what? Exponential. Okay, good. All right? Make sure you're focusing. Okay, good. Then the other one is 2 words, sequence and series. What's the difference between a sequence and a series?
Repetition. Repetitive.
That's right. Good job. Sequence goes on forever. If I have a sequence of numbers, it'll go on forever. We're not adding them up in this case. We're just having them go on forever. When you go to calculus, you'll actually add them up when they go on forever. It's called what? We could do that today too. It's not hard, but it's not required, so I'm not going to teach you. Okay? Sequence, okay? Series is when we take like a certain set of set of numbers and we add them together, okay? Like the World Series, right? What is the World Series? It's a set of how many games? 7 games, right? So we're taking a series of 7 games. We're figuring out we're going to add up all of the scores, and we're going to say all the wins and losses, and who's the winner, right? Does that make sense? That's why they call it a series. It's a set of 7 games. It's limited. Okay? Cool. All right. So those are the 2 things I wanted to talk to you. Today we're going to talk about geometric series, okay? So we're going to talk about an exponential model, which means we're going to talk about a rate, and we're going to add up a bunch of numbers that have been multiplied over and over again, okay? Okay, so if you're in the video, here are the steps. You have a goal equation, which is this one. The sum of all the numbers will be equal to the first number times 1 minus the rate to the nth number, all over 1 minus r. Okay? Then you're going to identify a sub 1, the rate, and the n. Then you're going to input the values and evaluate. Okay? Is that good?
Yeah.
Okay. Cool. Okay, here we go. Okay, so here we go. Numbers 1, 2, I'm going to show you, okay? So we know this is a geometric series right here because it's limited, right? So we're going to add up this finite geometric series, okay? And I know it's geometric because from 3 to 6 to 12 to 24 to 48 to 96, it's always being multiplied by 2, right? So that's my rate. So, and then my first number is 3. Okay, so what I'm going to do we're not trying to figure out what the sequence or the explicit formula here is, okay? That's here in green on your steps here on this board. Okay? We're just going to add up these numbers. Now, can I get someone in the room to add these up? Okay, cool. And you could all do it. You could add these if you want. So, but we're going to wait for Kaylee. These numbers on number 783. Did you add them or multiply them? That's a little too high. Let's try it again.
189.
Let's try it again. Cool, 189, right? Well, we had 2 numbers. I wanted to confirm it. You did say David said it first, and then Braden confirmed it. Okay, good. So we're confirmed, okay? Good. Okay, 189. That's okay. If we make mistakes, we need to confirm it. Okay? So, we just added it, which means we're done with the problem, okay? We are done. But we could have just added it, but I'm going to show you a different way to do it, which is how do we get the sum of a geometric series, which is this formula here, step 1, okay? So, I'm doing it on this easy problem so you can see that you get the same answer, okay? Because in harder problems, you might have to add up 25 numbers. Okay, are you going to go adding 25 numbers on your calculator? No. Especially when you don't know all of them, okay? So the way we do this is we take the formula from step 1, And we're going to write that down. And then we're going to substitute in the value. So a sub 1 in this case is 3. That's the first number. And then our rate or ratio here actually is going to be 2 to the 6th power, right? Because we have 6 total numbers. We have 1, 2, 3, 4, 5, 6 numbers, right? And then we're going to write 1 minus our ratio again, which is 1 minus 2, okay? So this gets a little bit, now it just goes back to, this is more of an advanced PEMDAS problem, right? Parentheses, we have some parentheses in the numerator. And the denominator is also its own set of parentheses, but we'll focus here first. We have exponents in here first, so 2 to the 6th power is going to be 2 times 2 times 2 times 2 times 2, which is, what? What's 2 times 2 times 2 times 2 times 2 times 2? 2 times 2 is?
4.
Times 2?
8.
Times 2?
16.
Times 2?
32.
Times 2?
64.
Oh, okay. 64. Okay. So then what's 1 minus 64?
Negative 63.
Ah, good. Awesome, okay. And then in the denominator, it's its own set of parentheses too, so we got 1 minus 3, or 1 minus 2, which is negative 1. And then, of course, 3 times negative 63 is negative 189, right? Divided by negative 1. What's negative 189 divided by negative 1?
89.
189, right? Isn't that the same answer we got when we added it all together?
Yeah.
Okay, now clearly the first way by adding them, if we know the numbers, it was way faster, right?
Yes.
But I wanted to show you the process here. You get the same answer, okay? Because on harder problems like on number 2, maybe you won't get to use your calculator. You have to work it out, right? Or maybe it'll be a lot of different numbers. So, okay, so number 2, I'll do this again using just the method we talked about. I'm not going to use a calculator to add. Okay, so the first thing I want to do is see if it's a common ratio, and I notice this is a geometric sequence, so I'm going to figure out what the common ratio here is, and this is negative 3. I know that negative 45 times negative 3 is positive 135. Positive 135 times negative 3 is negative 405, and so forth, right? Then I know my first number, a sub 1, is negative 45. And there's a total of, let's see, 1, 2, 3, 4. Oh, sorry, this negative sign has to go all the way here. Sorry. Let me move that over for you. This negative sign has to go all the way in front here, in front of. So we got a total of 1, 2, 3, 4, 5 numbers, okay? So I'm going to start off by writing down my my sum notation for a geometric series, a finite geometric series. And then I'm going to start replacing values. I'm going to replace a sub 1 with negative 45. My ratio is negative 3, all to the nth power. In this case, it's 5, okay? And then all over negative, all over 1 minus our ratio of negative 3, okay? So this gets a little tricky with a negative, so ready? Let's start with this exponent here. What's negative 3 to the 5th? Meaning what's negative 3 times negative 3 times negative 3 times negative 3 times negative 3?
427.
Okay. Dr. Griffin. That's right. Yeah.
For the top part of the 1 minus r to the n, how do you figure out the n?
N is the total number of numbers there.
Oh.
Yeah, good question. Okay? This 5 comes from the total number of numbers we're adding up, okay? Okay, back to you kids. What is negative 3 to the 5th?
700 and...
Nope, too high. Negative 3 times negative 3 is?
9.
Positive 9. Positive 9 times negative 3 is?
Negative 27.
Negative 27. Negative 27 times negative 3 is?
Negative 81.
Negative 81. What's negative 81 times negative 3?
243.
Positive or negative 243?
Negative 243.
Negative 243. Okay, thank you. So we're going to start simplifying it, right? And I know that 1 minus a negative 243 is positive 244, right? Did you all get that? Yes?
Yeah.
Sorry, got something in my throat. And then 1 minus a negative 3 is? What is it, everyone? I can hear your brains working.
2,245.
No, it's positive 4. Okay, good. Keep going. Thank you. It's like you're mixing. Good. Okay, let's focus. We're almost done. What's negative 45 times 244? Okay, this is hard, right? Get your calculators out. We're all participating now. What's negative 45 times 244? You can use the ones on your iPads. Your iPads are charged.
Negative 10,900.
Divided by positive 4?
2,745.
Good. It's going to be negative 2,745 is your answer. Okay? Is this difficult?
No.
No, it's kind of procedural. This is like very basic. You just got to go through the process. Okay? But the concept here is that you're adding a bunch of numbers together. All right? So, question, yes. R is the common ratio. So you think, what are you multiplying with to get from number to number? What do you multiply negative 45 with to get 135? 3. And you might need to get a calculator. Another way to do it is like divide 135 by negative 45. Go backwards. Okay? And then you keep going, you see, make sure it's negative 3 across. Good question. Okay? You think we could do 2 more together? I think you can handle it. Yes. No way, we are not done yet. We got, keep going here. Okay, here we go, number 3. Okay, here we go, number 3. What's the common ratio here on number 3, everyone?
Multiplying by 2.
Multiplying by 2, okay. Excellent. What's our first number?
3.
3, good. And how many total numbers are we going to add up together in this series?
3. 7.
3 or 7? 6? What? I'm hearing all these numbers.
Oh, 7, because n equals 7.
Ah, good. N equals 7. Good. So let's all write down this S sub n is equal to A sub 1 formula. Okay? And we're going to start replacing these numbers, okay? And I'm going to help you out with this one. I'll get you started all the way to this point. I want you to finish with your group, okay? Give you about 30 seconds to a minute, okay? Go. 128. The sum of 7 terms in this geometric sequence is positive 381.
Positive 381.
Good. What's the answer again, everyone?
381.
Oh, good. That's correct. Okay? Okay, let's try another one. Ready? Number 4. Okay, fractions. Uh-oh. You can handle it.
You can handle it. It just multiplies by 2. Dab.
Okay, at number 4, what is the ratio? How do you get like from 1/3 to like 1/9? What do you multiply with?
1/3.
Okay, 1/3 times 3 is actually 3/3, which is a 1. So that's incorrect.
My 1/3 actually.
Okay, what is it?
1/3.
That's right. 1/3 times 1/3 is 1/9. 1/9 times 1/3 is 1/7. So excellent. So what's our common ratio?
1/3.
1/3. That's right. And what is our first number?
1/3.
Good. So you're going to start with this, equation. Okay. So I'm gonna not do this problem for you. You're gonna go all the way. What's the answer?
Is it 1, 2, 43rds?
Shh. Okay. So on this one, let me see if I can help you out. So on this one, eyes up here. They shouldn't be a problem. Okay. No, they're not. Okay, here we go. Listen. Let's do this fraction here. What's 1/3 to the 4th?
1/3 to the 4th is going to be 4.
Okay, let's go slowly. What's 1 to the 4th?
4.
No, what's 1 to the 4th? 1 times 1 times 1.
That's 1.
Okay, slow down. So we know the answer has to have a 1 in the numerator. What about 3 to the 4th? Which is 3 times 3 times 3 times 3, which is?
81.
81. So this is equal to 1/81st, right? Right?
Or you can just leave it there.
Okay. Now, listen, if you had what's 1 minus 1/81st? Okay, let's think about this. If you had one whole pizza, children, and you divided it into 81 slices, and one person ate a slice, how many slices do you have left?
80.
80, right? Okay. Okay, this is our new numerator, and then our denominator. What's 1 minus 1/3? If you had one whole pizza, children, and someone ate 1/3 of it, how much pizza? Good, 2/3. Okay. That's the goal. Throwback Friday. Okay. So here we go. Let me help you out with this. The numerator and the denominator. It's a bunch of fractions. So just work in chunks. Okay. The numerator. Can we multiply 1/3 times 80 over 81? Not when you multiply. You just multiply numerator times numerator. Okay. Okay, the denominator we just bring down 2/3. Now, how do you? We have now a fraction being divided by another fraction, right? How do you divide fractions? Multiply by the reciprocal. You don't find anything. You just multiply by the reciprocal. Okay. Hey, Jonathan, you're not writing anything down. Kids, hey, I want you to know you can't learn by just watching. You have to actually do it. That's how you remember how to do it. And, of course, let you use your notes on the test. So if your notes suck, well, it's your fault. I'll just laugh. Because at the end of the day, that's what's wrong. It's not you're not doing your work. Okay?